Have you ever wondered how to create an AI chatbot that has superpowers? Superpowers? Yes, superpowers. Like being able to tell you the current weather outside, or even today's exact date and time, or even share a historical fact about today. You see, while foundation models are incredibly knowledgeable, they don't inherently know what's happening right this very moment in the real world. But with the right tools and a little bit of code, you can give your AI chatbot superpowers so it can reach out and grab the information it needs to save the world. Okay, maybe not save the world, but at least we can get our chatbots to do some really cool things like access the internet, other APIs, or even other applications. Now, enough of that. My name is Lightfoot. I'm a developer advocate here at AWS, and today we're building a superpowered AI chatbot. Let's get to it. First thing we need to do is create a simple chatbot leveraging Amazon Bedrock and the Converse API. To do this, we're going to import Boto 3. Okay, after we import Boto 3, the next thing we need to do is create a Bedrock runtime client in order to be able to communicate with Amazon Bedrock. After that, we're going to use the Anthropic Claude foundation model on Amazon Bedrock. So we'll create a variable for model ID for that foundation model. And if you're following along, one thing you need to make sure is that in the AWS console, you actually enable access to this foundation model. Here we're using the Claude 3 Haiku model, which is the lightweight, most capable, fastest model for Anthropic. Now, after we have our model, the next thing we need to do is to actually create a function that manages our conversations with Amazon Bedrock. Now, to do this, we're going to leverage the Converse API on Amazon Bedrock. What it does is it provides a consistent interface that works with all models that support messages on AWS. This allows you to write your code once and leverage different models within AWS in your code. Now, also what it does is for those different models, if they have unique inference parameters, you can pass those in via the Converse API. So you write your code once and use the different models within that code. Now, let's actually create this function and then go through what this actually should look like. So we'll create a function called conversation. And then we'll pass in our model ID as well as our messages. We'll talk more about these messages here in a moment. And what you're looking at is Amazon Q trying to assist us in creating our function. But we're not going to use that at the moment. We're going to create a variable called response. And now we're going to use the Bedrock runtime that we've instantiated already for our client. And we'll use this Converse API. So here we have our Converse API. And notice that Amazon Q was able to assist us with passing in our model ID and our messages. One thing I want to call out here is that I mentioned that it allows a unique structure or interface for you to be able to have different model communication. Well, another thing is that you can actually manage your messages history or memory within the Converse API. Notice that message is here and it has a list of your messages within the Converse API. Something to keep in mind is that when you're leveraging this API and you're using messages, they need to be structured a certain way. And the way they should be structured is like this. You have a list with the dictionary item in that list that is for the user. The role should be user, the content is in the list, and then with the dictionary key of text, and then the value for that key. Now, the next item within that list is going to be the role of assistant. And this should be alternating. So you have one entry or item in your list that's the role of a user. The next item or in your list should be an assistant. And notice this is how it should be structured here. So let's go back to our code. And the next thing we're going to add is a system message. And what this system message does is it instructs our foundation model on how to respond as our chatbot. And here we just want it to be a helpful assistant. We'll keep this simple. Now, the last thing we're going to pass in is our inference config. Our inference config is going to control things like our temperature. And if we go back to our documentation here, and we scroll down to our inference config for the actual API documentation, notice that for inference config, we can pass in things like the max token, the stop sequence, the temperature, and the top peak. Now, there is an option for additional configurations as well that you may want to pass in, but we don't need those, but we'll keep it simple and just use a temperature of 0.5. Now, from there, we have our response for our foundation model that we want to return, and it needs to be returned like this. Now, I have previously created a more detailed video for the Converse API. You can check that here if you want to watch that and learn more, but we will be covering some things like tools in this video. So let's go through, and we have our conversation. The next thing we need to do for our conversation is create a messages list. This messages list is what we'll use to be able to append our role of our user and then the role of our assistant in alternating entries in our list and send that to our foundation model so it can have context of our full conversation. Now after that, we'll create a while loop that will leverage, and I'll actually just paste this in to keep this simple and save time for the video. So we'll paste this in and go through it. So this while loop is going to say while true, we're going to take a user response. So here we're going to print you, and then we'll take the response from the user. And then if the response is exit, we'll exit the script. If the response is history, we're actually going to print these messages so we can actually see the history of the messages that have been sent to the foundation model. And then after that, we'll just take another entry from the user. Now from there, we're going to append that to the messages list so we can see the entire list. And then we take this entire list and we send it to the foundation model in order to be processed. Once that response is returned, we print the response and then we append it to the messages list. Let's actually run this code and see it in action. Okay, now I'm going to run the code and our chatbot will start. So notice that we are now inside of our chatbot. So we will ask it, how are you today? And we get a response from our foundation model. The next thing I want to ask it is, what is the date? And like I mentioned before, if you're using a foundation model, it does not have any context or awareness of what today actually is. Now, it has an understanding of its training date, but for the date of today, it has no temporal awareness of now, the outside world, or the date. So in order to do that, something we could do is actually leverage tools within the Converse API to provide additional information or context to the model so it can leverage that information, process it, and form a response. So we'll go here and actually print out our history. And notice that I mentioned before about the messages within the Converse API, how they should alternate. So here we have a role of user, assistant, and that's the way the structure and alternating of the messages works. Now we'll exit this. Before we move on, one thing I want to show you is what happens when you don't structure messages correctly. So we'll go back into our code. I'll pull that down, and I'm just going to do something simple. I'm actually going to just comment out this message here. And then we're going to run our code again. I'll scroll that up there so we can see it. Notice that we have not appended the AI response to the message. So we'll come down here and we'll clear this out and we'll run our code. So we'll do Python and tools. So our code still runs. We're able to ask a question. So how are you? And when we ask this, the foundation model responds appropriately. But if we ask it another question, what is today? Notice that we get this error letting us know that a conversation must alternate between user and assistant. So this is what happens if you do not structure the messages correctly within the Converse API. I wanted to show you this error so you know when you see it, what's actually happening and how to solve it within your code. You're going to go back and you're going to review the messages list to ensure that your messages are actually alternating with user and assistant and being sent to the model appropriately. Now, some challenges you may run into when you're creating this messages list by leveraging the Converse API within your application is that as you append messages to that list actually grows. And as it grows within your application, you could actually run out of memory or your application could slow down. So you actually have to handle those messages. Another challenge is that when you send your messages through the Converse API to the foundation model, is that these appended messages are all being sent to that foundation model. And depending on the foundation model that you utilize, each one has a particular context window size. And if you send these messages to that foundation model, you could actually fill up that context window and run into issues within your application. So you have to figure out how you want to handle those messages within the Converse API. One way to do it is by summarizing those messages within the messages list. Another way is that you can do a sliding window. Older conversations are removed from the list and newer conversations are added. That's one way that you can do it. And another way is you could actually summarize the older messages within the messages list. That way the model still has a context and understanding of your conversation within the Converse API. Okay, now that we discussed that, the next thing we want to do is actually give our model the ability to understand what today is and also what today's time is. So the way we'll do that is we'll create a function, and that function will leverage the date time built-in library from Python. Okay, now that we imported date and time, the next thing we need to do is create a function called getDateTime. And what this function does is it gets the current date and time in the Eastern time zone and then returns it in a dictionary format that the model can understand. We'll talk more about this in a moment. Now we need to modify our actual conversation function within our application in order to be able to process and handle the tools. And the way we're going to do this is by leveraging tool config. If you come over to the API documentation, notice that we have this dictionary or JSON for tool config. And if we scroll down to tool config and look at the documentation, it lets us know that this configuration for the tools, the model can use to generate a response. And it lets us know the supported models and features. So you want to ensure when you're leveraging this that your model actually supports it. So if we come back here and we add a comma at the inference config, and we come here and we're going to add tool config. We want to ensure that we close our list and we want to close our dictionary. So now inside of tool config, we have a list of tools. For now, we're only going to add one tool, and that's the tool of getDateTime. We give it a description, get the current date and time in the Eastern time zone. Our input schema. This needs to be the JSON. It lets us know that the type is object. Here are the properties, and there are no keys or values that are required from the user when we're trying to use the tool. And we'll talk more about some values that are required here in some other functions that we create. Okay, so once we actually have our tool within the Converse API that we send to the model, the next thing we need to do is ensure that when the model recognizes that it needs to leverage this tool, that our application is able to orchestrate or route the request to the API to gather the data and then send it back to the model so the model can formulate a response that's returned to the user. And you'll see how we do this in a moment. Now, one thing I want to call out is that this getDateTime could be any API. We just created a function, but you could actually call other APIs to get data and return it back to the model. This is just one example. We'll do a few more here in a moment. So if we scroll down, we're going to create a new function. And this new function is going to process our responses from the model. So we'll come in here and we'll add our new function. And we'll take these out because we don't need them. In this process response, we actually pass in the AI response, and you'll see why in a moment. And then we also pass in the entire message history to this function. So once we have this AI response, we're going to process it and look for content. And if the content next value is text, then we're going to print the response from the model. And so if we actually look at the output from the Converse API, notice here that we have our output, our messages, which we handle in our conversation function. And then we actually look at this content, and then we look at the value for text. And if this is text, then we pass that and print it to the screen. And then from there, we just return the messages back to the application. Now, what if it's not text and it's tool use? This is the response from the foundation model that tells the application that we need to leverage a tool. So we'll take this response of tool use, and then we'll process it to determine, okay, what's the name of the tool? And I'll print this out in a moment so you can actually see what this looks like. We're going to print out check the date and time with this tool. Great. And then from there, we get the date and time in our function tools list. And then we process this and it appends it into a messages list that the model can understand. But we need to ensure that the role is user rather than anything else, because remember that the messages need to be alternating user and assistant. So we already have our assistant message. The next entry in that list or item in that list needs to be user. So here we have our user, and then we have our content and our tool result. This lets the model know everything about the tool. And notice that here we have our tool result because we're calling our tool here. We call our tool here to get the response from our function. So this actually takes the tool functions and calls get date time. So it calls this function, gets the result of the current date and time, and then we pass it back to the model. And then from there, we send this entire message history or list to the model. The model is able to process it and then give us a response. So this is actually how it works. We're going to add one more item here to ensure that our messages are being processed and then returned to the screen. So we'll add a line here. And now when we run this code again, you're going to notice that now we can get the date and time from our model. All right, so we'll run our code and I'll just ask the model, how are you? It'll give us a response. Great. Now let's ask it, can you tell me today's date? What is today's date? And notice that it actually says, okay, let me check the current date and time for you. It lets us know that we're using the get date time tool because I actually put this in our code so we know what tool we're using. And then it tells us today's date is September 12th, 2024. What about the time? What about the time? So we asked it today's time and we verified that this is the correct time within our application. Now, what if I want to ask it about the weather in New York? Can you tell me the weather in New York? And we notice that the model is unable to tell us about the weather in New York because it does not have access to any tools or any awareness or any eyes to see what's going on in New York. So we'll exit this and then we'll actually create another tool that's going to get the current weather in NYC. Okay, so we go back to our application, we scroll up, and under date and time, we're just going to create a new function that's called get weather. Now, this new function here is going to be mock data. Now, you could leverage a weather API to actually get the current weather, but what we want to do is actually just mock this, create a function that's going to work, and you can try this on your own. Now, the weather locations that we'll have is going to be New York, London, and Tokyo. We put the temperature and we actually say the condition for that location. And then we return this depending on the location that's passed in from the model. Now we need to handle this within our code. So inside of our tool config, we need to add a new tool. So if we come down here to our tools and we put a comma here, and then we'll add a new tool here. And so now we added a new tool called Get Weather. This tool has a description of get the current weather for a specific location. Now, inside of this tool spec, you'll notice you have an input schema of a JSON that contains an object, and that object within this JSON has properties of a location. This location is of type string, and the description is the city to get the weather for. This is all information that's passed to the model so the model understands how to use the tool. Now, another thing is that in order for the model to use the tool, it needs to know where the location is. And so we tell the model that the required property or key that you need to be able to leverage this function is going to be location. Now that we added our tool to our tools list in the Converse API, the next thing we need to do is update our tools function to be able to process and handle this tool. So we'll add a new entry to our dictionary. And this time, this entry is going to be a get weather key that contains a lambda that passes in our actual location. Let's modify this using, because before we had it to check the date and time, but since we have different tools, we're just going to say which tool we're using. And then from there, there's nothing else we have to modify because our code is portable, and all we have to do really is just update this tool's function, and then the rest of the code will do what it's supposed to do. So let's open up our terminal and run this code, and then find out what the weather is. We'll ask it, we'll just say, how are you, just to get a response. And we get a response from the model. Now, I'm going to ask it, can you tell me the weather in NYC? And it knows, okay, using the Get Weather tool, based on the weather data, the current temperature is 20 degrees, and the weather condition is currently unknown. Let's actually go up to our tool and see if it worked properly. So if we look at this, our function for New York, it says the weather is sunny. Now, this data, if we look at our code, was passed into the model, but it did not respond appropriately. There's a reason for this. One thing that we did not do is help the model understand how to respond and know the tools that are available when we're leveraging our Converse API. And so what we need to do is modify our system message. Let's do that now to give it more detailed instructions on how to handle responses within our code. Okay, I'm gonna make this just a little bit smaller so we can read it. So I created a really long system message to give the model as much information as it needs to understand what it needs to do. So I tell the model that you are a helpful AI assistant named Claude, designed to provide accurate information about the current time and date, weather conditions, and historical facts. Now, the primary function is to assist users with queries related to these specific topics. Please adhere to the following guidelines. And then I give it guidelines to know the tool usage, the response scope, the boundaries. I'm providing guardrails at this point, clarity and conciseness, privacy and security, as well as ethical considerations. I'm giving the model all of this in the system message, so the next time I run this application, it knows how to handle the tools. Now, before we handle this, let's go ahead and add our historical data function as well, so we can just run it and then close out this demo. So I'll add a function here for get historical facts, and then I have some historical facts about today, which is September 12th, 2024. And on this day, throughout history, I looked up some facts on the Encyclopedia Britannica, and then I just put them in a list, and then I'm selecting a random item in that list for this specific date. So now we also need to import random. So import random. And now when we execute this function, we'll take a random item from this list. The next thing we need to do you know? You guessed it, we need to update our tools list in our tool config. So we'll place a comment here. We'll paste that in, and then we'll remove that. And now we have our get historical fact entry in our tool config list. We also give it this tool choice. So we let it know, the model know that it has the ability to automatically select which tool to use. And so from there, we update our function to add the get historical facts. In the process response function, we just add that there. Now it's going to call this get historical fact whenever we ask about a historical fact that took place today. So let's run our chatbot one more time. This time we're going to ask it what is today. And notice that it leverages the get date time tool, and it lets us know what today is, September 12, 2024. Now let's ask it what is the temperature in London. The temperature in London is 15 degrees. And the condition is cloudy. So if we go back to our function and look at the actual temperature in London, it's actually 15 degrees. What about Tokyo? What about Tokyo? 28 degrees and the condition is rainy. Perfect. So this is working how we want it to. The next thing I want to ask it is, can you tell me a historical fact about today? And now notice that it used the get historical fact tool here. And then it tells us that on this day of September 12th, legendary Olympic athlete Jesse Owens was born. Awesome. What about another fact? What about another fact? It uses the tool again, and this time it tells us that astronaut Mae Johnson became the first African-American woman to fly into space as part of a NASA mission. This is amazing. I think leveraging tools gives us endless capabilities to superpower our AI chatbots. Last thing I want to do is actually look at the history so you can actually see the conversations within this tool. And so if we scroll this up, you can actually see the entire message conversation that we've had. And notice the first question I asked was, what is today? This is the role of user. You see the response from the assistant. And then from there, my next question that I had for the model was from our application that tells the model the tool to use. So this response was in our function that we kind of built out, and then it contains the date, the time zone that's sent to the model. The model is able to read this as a user response because it kind of assists the model in answering the question. And then from there, the model is able to generate a response. So the assistant responds, okay, let me check the current date and time for you. And then notice this tool use here. It has the tool use ID and then the name of the tool that it needs to use. This is actually what's sent back to our application. If we scroll down in our process response, right here. And so this is the tool use that we're actually looking for in the response from the model right here. And we process this to determine which tool to use in our tool functions. And then from there, we're able to send this back to the model so the model can generate a response from the functions that we have within our code. Okay, this completes our demo on building a superpowered AI chatbot on AWS. If you have any questions, leave them in the comment section below. We hope you enjoyed this video. Please remember to like, share, and subscribe to the AWS Developers YouTube channel. I will catch you on the next one. Thanks again. Peace.